Alright. So in this video, we're going to do a few modifications on our algorithm for finding the index of the smallest element of the array. Now, we know that from the previous video, the algorithm that we had written works pretty fine, right? But we can still make it a little concise by removing a few statements from our algorithm. Okay. So for finding the index of the smallest element of the array, we don't really need to store the smallest element of the array, right? We don't need to keep track of it. Okay. To accommodate for those, we can delete a few statements from our algorithm. So we no longer need the variable smallest. So I'm going to delete this off. I'm going to strike this off. We no longer need to store the smallest element of the array, and no longer need to assign it anything. But doing this, we need to change our condition first, because we don't have the variable smallest available anymore. All right. So I'm going to scratch this off, and I'm going to give you a task. Think for a moment, what should the condition now be, now that we have deleted our smallest variable? Can we get back the smallest element from the array from the smallest index that we have? Think for a moment. Can we? Well, we surely can. If we have the index of the smallest element, then to get back the smallest element, what we can write is ARR smallest underscore index. And this would fetch the smallest index of the array. We don't need to store the smallest, not the smallest index, I'm sorry, the smallest element of the array. Now we no longer need to store the smallest element in a separate variable. We no longer need to keep track of it. So doing this makes our algorithm a little concise. All right. Now the same set of changes can be done for finding the index of the largest element as well. Okay. So here we would scratch off the variable's largest everywhere that it occurs. Remove this, scratch this, sorry, scratch this as well, and scratch this. So same task as before. How can we figure out the largest element of the array from the index of the largest element? Think about it. Well, we can do that by writing ARR largest index. Alright, so doing these changes to our algorithm, we can make the program a little concise, because while finding the index of the largest element, for finding the index, we don't need to store the element, right? We don't need to store the element. Storing the element is redundant, because that does not form a part of our output. All right, so let's see what few changes we must do to our program to accomplish this, to make it more concise. All right, so this is our program from before. So we don't need this statement. Moreover, we don't need this, and we don't need this. So let's get rid of these statements. At 927, get rid of smallest, and instead of smallest, we can get back the smallest element of the array by writing ARR smallest index, because that is where we store the index of the smallest element. We don't need this as well, and that's it. Our job is done. Let's do the same set of changes in the largest element index method as well. So we don't need this line, we don't need this, and get back the largest element from the largest underscore index. We would write ARR largest underscore index. Let's compile our program, and that's it. Let's test if it gives the correct output as before. So let's run it. First, let me head on to the example array that we had from before. So, okay, all right. Let's run this. Remember that this is a changed or modified program. This is not the same As before, this has been changed. We no longer store the smallest element of the array. So now we have 7 elements in the array. The first element is 38, next is 41, then it's 18, 50, 68, 32, 34. So our array is this, and the index of the smallest element of the array is 2, which is true because 18 is the smallest element and it has an index of 2, 0, 1, 2. And the index of the largest element is 4 because 68 is the largest element and it has an index of 4, 0, 1, 2, 3, 4. Alright? So doing these changes, our program didn't break, our program is correct, our algorithm is correct, but we have made it a little concise. Alright? So let's see you in the next one where we will discuss the algorithm for selection sorting. Bye for now.